now let's move to the second question here. See, second question is again based on a result, but that result is quite a direct one. So first let us look at the parabola. Isn't that a vertical parabola, and how do we convert it to the standard form? Because when we say vertical or horizontal parabola, that means we need to compare, or we can compare it with y square is equal to 4ax for horizontal parabola and x square is equal to 4ay for vertical parabola. So if I write it here, x square minus 6x is equal to minus 4y, and completing the squares, for that we need to just add 9 both the sides, minus 4y plus 9. So we have x minus 3 whole square, and taking minus 4 common, y minus 9 by 4 here. Okay. So that's the parabola. Now length of lateral sectum is 4. Axis, equate the second perfect square term to 0. So x minus 3 equal to 0, that's the axis. Okay, if we have to get vertex, then equate this. So this is equal to 0, this is equal to 0. Their point of intersection, see these are two lines. This is vertical, this is horizontal. Their point of intersection will give us the vertex. So what is it? So it's 3 comma 9 by 4. So likewise we can find out everything, but what do we need? We need to find consider 3 points on the parabola ABC such that normals at A, B and C are concurrent. Find locus of centroid of the triangle ABC. Okay, so as I said, that's again we have a result for this. So the result again I will be showing it for the horizontal parabola, because if you people remember, normally we discuss the slope form of equation of parabola for standard horizontal parabola only. Okay, so it has its own long discussion. We have a result there. That result is extremely helpful. Okay, so what we say, that's the equation of parabola drawn at the point am square comma minus 2am. That's the equation of this normal to the parabola drawn at this point. If I say it passes through the point alpha comma beta, you substitute this point here, we get beta is equal to m alpha minus am cube minus 2am. Now bring all the terms to LHS. So what we get a cubic in terms of m bachon. We get cubic in terms of m. Okay, now see, from here comes that logic. What? That if it has 3 real roots, if it has 3 real roots, though there are conditions, one condition I am writing it, which you can always check very directly for horizontal, of course, that work only for horizontal standard parabola, and alpha should be greater than 2a. Okay, but if it has 3 real roots, that means you will get 3 slopes, and slope of what? M represents slope of normal, so you will get 3 different normal, and all are passing through the point alpha comma beta. Okay, so from there we get that concept of 3 normals being concurrent bachon. Okay, so I am just removing it from here. So 3 normals being concurrent. So draw one normal like this, draw another one like this. Okay, so this is the triangle formed by the full feet of normal. Here the question was, if you have 3 points, let's say this is P1, P2, P3. Normals drawn at P1, P2, P3 are concurrent, meet at a point. That's so we are given the statement in the form which is the reverse of what we are discussing here. Okay, in any case, see the result is if we go for its relation between the roots and the coefficient of equation, we can write m1 plus m2 plus m3, sum of all the roots. Since there is no quadratic term here, the sum of all the root is 0. Okay, and in that case it will be the feet of perpendicular, these points. So if I mark these points here, it will be a m2 square minus 2a m2, a m3 square minus 2a m3. Okay, centroid. So if I write the coordinate of this centroid, it has some abscissa. Importance is of ordinate, and which is, now since we know sum of all the slope is 0, so that means centroid always lie on the x-axis. So that's not important, x-axis. The result is important, and say that means, and x-axis actually is being the axis of the parabola. So centroid lie on the axis of parabola, and that's it. Okay, so for any such cases, the centroid for any such triangle formed by the feet of normals, 3 normals drawn from a single point or all passing through the same point, the centroid, its centroid will always lie on the axis of parabola. So without any calculation, the locus of centroid of triangle ABC will be the axis of this parabola, and as I've already shown you, that's the axis, so that's the locus and that's our answer here, bachcho.